Okay, another review topic we have is working with multipliers and exponentials. We're going to do a couple different types of problems over the year, just so you guys don't forget about how do you work with exponentials, just like we don't want you to forget how to work with linear equations either. So when you work with multipliers, remember, start with 100%. So we're going to find the multiplier that corresponds with, well, an increase of 5%. So I would do 100% plus 5%. This gives me 105%. So my multiplier is equal to 1.05. I moved my decimal over 2 spots, change it from a percent to a decimal. A decrease, so that means my multiplier here is 1.05. Decrease of 13%. Again, I start with 100%. I lose 13%. It's a decrease. So this gives us 7. That changes to 9. 9 minus 1 gives me 8. So it's 87%. My multiplier here is equal to 0.87. I like to put the 0 in front so that I don't lose track of where the decimal is. A gain of 0.3% each week. Again, we start with 100. These are the ones that you really want to do the extra step of writing this. Plus 0.3%. This gives me 100.3%. So my multiplier is going to be 1.003, not 1.03. It's a real common mistake that students make. Depreciates 5.7% each month. Okay, depreciate means lose. So 100%. I lose 5.7%. That's going to give me 94.3%. So my multiplier on this last part was equal to 0.943. And again, I like to add that 0 in front just so I can know where the decimal spot is. Okay, so let's look at a typical example. So the population in Placer County is increasing by 2.7% each year. Right now, the population is 372,400. Okay, for an exponential equation, anything you have increase or decrease by a percentage, it's going to basically have this format. It's y is equal to my starting value, which is a, my multiplier raised to the x, and I got to be careful of my time units I'm working there. So on this particular problem, my equation, I'm starting with 372,400. My multiplier, I increased by 2.7%. So again, if you didn't know how to get that, 100% plus 2.7% gives me 102.7. Move my decimal spot over, it's 1.027. Don't round that to 1.03. It totally makes the error huge. So you never want to round whenever you work with exponential functions because your error gets raised to a power, which makes it a really big error. Okay, they want to know if assuming the rate of growth is constant, you still have that 2.7% rate of growth. I want to know what will be the population in 10 years. Well, I'm working in years. This is each year. So all I just got to do is replace x with 10. Punch in the calculator, and we get 486,807. Another kind of a problem you have is ask what was the population 20 years ago? If you're going in the past, forward is positive time, backwards of time is negative time. So we've got to travel into the past. So I'm going to raise that equation to the negative 20th. Raising it to negative 20th, I'd have a population of 218,575. Real typical kind of a problem you would come across. Not too difficult to work with. Eventually, we're going to have to worry about solving for a multiplier or finding the time when something gets to it. That'll come up later. Let's look at another problem. So on this one, it says, Mrs. Jeffries has a smartphone that is currently worth $400. As the phone ages, it decreases in value, so it depreciates. Each month, it loses 2% of its value. So, if I'm looking at my equation, I'm starting with 400. It loses 2% each month. My multiplier is 0.98 because I have 98% left over. X is measured in months. So I want to know, what will Mrs. Jeffrey's phone be worth in 2 years? So I'm going to have to, I don't plug in 2. This is 2 years, but this is happening every month. So you got to be aware of what you're working with. So I'm going to replace the 2 with how many months it is. There's 24 months in 2 years. So I raised to the 24th. That means her phone will be worth $246.31. So phones are actually pretty expensive. A lot of people get them for free or a real big discount because they make a deal with the phone company to use their phone service for 2 years. But you could actually flat out buy it straight out and not have to be stuck with the plan. Okay, if she bought it 6 months ago, I want to know what was the original value of the phone. Well, 6 months ago, I got to go 6 months in the past, so I'm going to replace that 24 I have here with -6. And when I calculate it out, her phone would have been worth $451.55.